Express 108 has a product of its prime factor. We are going to draw the prime factors. One zero eight. 2 5s are 10, 2 4s are 8, 2 2s are 4, 1 carry forward, 2 7s are 14, 3 9s are 27, 3 3s are 9, 3 1s are 3. So prime factors are going to be 2 times 3 times 3 times 3. And we can write it as raised to power 2 times 3 raised to power 3. In the next question, it says that written as a product of its prime factor, okay, and highest common factor is given, lowest common factor is given. Now we are going to solve them. Okay, there is a formula to solve them. As there are two numbers, okay, so the product of two numbers is equal to LCM times HCF. That is equal to the product of two numbers, and the product of two number is number n times 500. Whenever this kind of question comes, you need to use this formula to calculate your value. Okay, look, how will I do that? LCM. My LCM is this one. This is my LCM. So and this is my HCF. My LCM is 2 raised to power 3 times 5 raised to power 3 times 7 times HCF. HCF is 2 raised to power 2 times 5 raised to power 2. Now it is equal to the product of the number, and n is 2 raised to power p times 5 raised to power q times 7 raised to power r, and it will be timed with the 500 prime product factors of 500, and they are 2 raised to power 2 times 5 raised to power 3. Now you can see that when base is same, power is going to add up. Okay, so same base, power will add up. It will be 2 raised to power 3 plus 2 times 5 raised to power 3 plus 2 times 7 raised to power 1 as it is. And over here again, base is same, so power is going to add up. These are the same bases, so I will add them up. 2 raised to power p plus, because base is same. There is one more way. If this is same, this is going to be difficult for you, then we can write it as, let me tell you. First, we are gonna pick up the same values together. Those values whose base is same. Raised to power 3 times 2 raised to power 2. Then 5 raised to power 3 times 5 raised to power 2 times 7. When you will be having a solid grid, then you can skip that step. So 2 raised to power p times 2 raised to power 2 times 5 raised to power q times 5 raised to power 3 times 7 raised to power r. Now base is same, so power is gonna add up, and we will be writing this as 2 raised to power 3 plus 2 times 5 raised to power 3 plus 2 times 7 raised to power 1, and it will equals to 2 raised to power p plus 2. Same way, 5 raised to power q plus 3 times 7 raised to power r. As we can see from here, according to the rule of mathematics, when the base is same, so their coefficients will be automatically same. Now I'm going to make the coefficient same of the same basis. You need to apply that sign. Okay, if you are going to do this shows that, this implies that shows that I'm going to do a direct step. So it was 2 raised to power 5. First, let's simplify their answer. 2 raised to power 5 times 5 raised to power 5 times 7 raised to power 1. It cannot add it up, so it will remain as it is, times 5 raised to power q plus 3 times 7 raised to power r. Now I'm going to do the next step. I'm going to compare their coefficients of the same basis. Okay, so first, right now you can see that my this and this, these two are the same coefficient. So I'm going to make their, as the base is same, so I'm going to make them equal. You are going to do this by using this sign, implies that sign. Okay, you need to put that sign and then do this step. As you can see that base is same, so we can cancel that base and their power will automatically be equal. 5 is equal to p plus 2. Let's separate p from here. So it's going to be 5 minus 2 is equal to p. So here my p is 3. That is the value of p. All right, now let's do for 5. Okay, As you can see that 5 raised to power 5 and 5 raised to power this one. I'm going to compare their base and their power as well. So let's put implies that sign. 5 raised to power 5 is equal to 5 raised to power q plus 3. As base is same, so it is cancelled out and their power will be equal. 5 equals to q plus 3. Let's separate q from here and I will be getting my answer as 5 minus 3 is equal to q. That is 2. So here my answer is 2. That is my answer. Now one last variable is left, which is 7 raised to power 1 and 7 raised to power r. That is left. I'm going to compare their coefficients as well. I'm just going to do this over here. So by comparing their coefficients implies that, sorry, not coefficients, comparing the power and the base as well. 7 raised to power 1 is equal to 7 raised to, eventually its power will be equal, which is r equals to 1. Now we have made our variables clear. So P is 3 and you can see Q is 2 over here. This is Q. Q is 2. It is not visible. So P is 3, Q is 2 and R is 1. That is my answer. Let's move to next question. Next question says that express 154 as a product of its prime factors. All right, we are going to figure out the prime factor by using ladder method. Let's do that. 154. It is 2 raised to 2 sevens are 14. 1 carry forward 2 sevens are 14. 7 ones are 7. 7 ones are 7. 11 ones are 11. 7 times 11. These are the prime factors. Now it says that find the lowest common multiple like LCM. 49 is 7. 7s are 49. 7 ones are 7. So it's going to be, I'm going to write their factors now. 154 7 times 11 and 49 is having factors as 7 times multiples. Okay, it means that first we need to figure out, make a loop. So the loop is this one. So all common multiples. It shows that the loop one will come once. Like look, they will appear as single time. Okay, either they both are common, so we will write them one time. And non-loop one will be written as it is. 2 is a non-loop. Same with this 7 is a non-loop. 2 times 7 is present, so I will write it once because that is a common. And 11 will be written as it. Find the lowest common multiple. Okay, now I'm going to multiply them. So by multiplying them, 7 sevens are 49 times 11 times it is 1078. 1078 is my answer. Here it didn't say that leave your answer in the form of prime factorization. So that's why I need to find the whole number after multiplication. If he would want us to leave our answer in the prime factorization, then we need to leave it in that way. It is given that P and Q, okay, express your answer in the standard form. Over here, this is the denominator, like P over Q. Let's divide them. So first I'm going to solve part 1. Part 1 says that fifth question, part 1A, first part P over Q. Let's 5 over 8 times 10 raised to power 6. As we know that when base is same, so power are gonna subtract, okay? And over here we will subtract 1 by 2 times 10 raised to power. Bases are same, so power is gonna subtract 5 minus 6, and 1 divided by 2 is 1. Now look, we need to convert this into standard form because it mentioned it into standard form, and standard form we have done in the previous lectures. If you want to revise your previous lecture, then you can see in the YouTube channel. You will be able to find that video. So in the standard form, it says that if we want to convert this form into standard form, we need to move our decimal in such a way that it should move up to after first non-zero digit. Okay, so 5 is the first non-zero digit. I will move it after 5. So it will be 5.0, and you can see that our decimal has moved from left to right. Whenever it moves from left to right, the power is going to be -1 because it has moved up to 1 digit only. And this will be minus 10. 10 is for minus 10. It was already present. Now base 1 plus -1, which is -2. 5 raised to power 10 raised to power -2. That will be our answer. Next part says that express this answer, let me -2. Now in this part, it says that take the cube root of that second part. And I'm going to calculate the cube root of q. All right, so I'm going to write it, the value of q. Value of q is 8 times 10 raised to power 6. Let's factorize. 2 2s are and 2 1s are. Since we know that cube root or square root, if a number is having a cube, if I want to remove that cube root, then I have to write this in the power of 10, power of 1 by 3. Then I can remove my cube. Square root is 1 by 2. If the value over here defines the power worth of our root. Okay. So here this is my cube root, and this, if no value is present over here, then it will be a square root 1 by 2. Then its value will be 1 by 2. If n value is present over here, then the power of my a will be 1 over n. Okay. We will be doing this in indices as well. So here I'm going to find the values. I'm going to split them up, okay? Because I told you before that if our value is present in the form of multiplication in square root, cube, root, or any under root, then we can split them up because it is having multiplication, and it is possible only for two conditions, either in multiplication or division. If there will be, now my value will be 2 raised to power 3 times 10 raised to power 6. So it will be 10 raised to power 6 times 1 by 3. As I told you before that, whenever I need to remove cube root, I have to divide it with 1 by 3. I have to take the power of 1 by 3. So I'm going to multiply it with 1 by 3. 3 1s are, 3 2s are. So this 3 is going to be cancelled with this 3. Okay. Same way, you can also put this value just like, or if you don't want to do it, then we can do it as raised to power 3 into 1 by 3 times 10 raised to power, like I already have cut this one, so simply it's going to be cuttable like that, and it will be 10 into 10 raised to power. That will be my answer for this part. So 2 times 10 raised to power 2, that will be our answer. Now in the next part, it says that, all right, is a multiple of 540. We need some space, so I'm going to do this question over here. Just give me a moment. All right, I will try to do this over here. Okay, 220 as a 2250 as a prime factor. I will do this in the above section. Okay, so first let's do the second part over here because we have less space over here. So I'm going to do this, the second part over here. It says that find the smallest possible integer of n for which 225 by n is a multiple of 540. Whenever this kind of question comes, it means that if a number is a multiple of any number, then that number is going to divide it into a complete whole number, like without leaving any decimal. So it means that if 225n is a multiple of 540, then 225n should be divisible in such a way that denominator is all going to be n completely. Okay, like it means that, just like if I'm saying that 12 is a multiple of 4, 12 is a multiple of 4, it means that 12 is going to be divisible by 4 in such a way that denominator is all going to be vanished. 4 1s are, 4 3s are. Like denominator is finished. Like I got a whole number, okay? No decimal is left because if the denominator will be present, then decimal will be present there. So I'm going to write there prime 2. There is n. So instead of n, I'm going to make a box in it. I'm going to make a box in such a way that, so let's see that what value can we put in that box. All right. And now 540. The prime factors of 540 are 3 raised to power 3 times 5. All right. See, you can see here. Let's cut them. This 5 is going to cancel with this power and 1 5 will be left. 3 raised to power 2. This is going to cancel and only 1 3 will be left and 2 raised to power 2 is left. Now the n, the value of n will be those numbers which are left in the denominator. Those numbers are the value of n. So I left with 2 raised to power 2 and single 3. That will be my value of n, because if it is a multiple of 540, then it means that n will be having this value, then it will become a multiple and whole denominator will be cancelled with this. Okay, so how are you going to calculate this? by whatever is left in the denominator, you will be put this as a value of n. Understood? This kind of questions will come again, and we will be doing this again as well. So look now, I'm going to write there as 2 raised to power part 2. N is the value of 2 raised to power 2 times 3, which is 4. 2 raised to power 2 is 4. 4 times 3 is 12. So 12 is the answer. Now let's do this part. It's 2250 as a prime factors. I need to find the prime factors of this. Let's do this over here in this space. Part 1, 2250. So 2 ones are 2 ones are 2 twos are 4, 1 10, 2 fives are 10. Now there is a 5 at the end, so I will choose the prime factor of 5. 5 twos are 10, carry forward 25, 5 fives are 25. Same way, 5 fours are 20 and 2 carry forward, 5 fives are 25, 5 nines are and 3 ones are 3. So you can see that my prime factors are going to be over here. I'm going to write it over here. 2 times 5 times 3, and which can also be written as 2 square. So here my answer will be 2 times 5 cube times 3 square. That is my answer. Let's move to next question. Okay, next question says that express 196 and 98 as a product of its prime factor. So let's do that. 198. 2 nines are 8s are 9, 3 threes are 9, 3 ones are 3, 3 ones are 3, and 11 ones are 11. So my answer is 11, or it can be written as 2 times 3 square times 11. That is my answer. Now it says that find the largest number that divide exactly into m and n. We need to calculate the largest number. All right. As it says that find the largest common number that divides exactly into m and n. Largest common number. It means that they want us to calculate HCF. So we are going to calculate their HCF. In order to calculate HCF, we want that we will be figure out their common part. So you can see that this value is bigger than this one. Okay, so what will I be doing? I have to split them up. If I told you before, when base is same, so power is going to add up like 1 times 2. When base is same, so power will add up. So if there is a power, like if a number is having a power, so I can split it up into backward condition to make them two bases. So same way, I'm going to split this one and this one so that I can have a common with that. So you will be able to see that n is going to be 2 raised to power 2 times 2 raised to power 1 because it was 3. Same way, I need to make it common with 3. Now I'm going to write, let me write this over here. N is 2 raised to power 2 times 2 times 3, and it will be like that. Same way I'm going to write my n, and m is 2 raised to power 2 times 3 times 5 square. And I told you before that largest common factor is going to be two ones, only the common ones. So these two are common times 3. Because whenever two quantities are common, we have to write them once only. You don't need to write them again and again. 2 raised to power 2 is 4. 4 times 3 is 12. So 12 is my highest common factor, which is going to divide these two quantities exactly. Now next part says that find the smallest value k such that m times k is a cube number. Okay, let's write m. M is m times k. First, I will write the factors of m. M is 2 raised to power 2 times 3 times 5 raised to power. I have made a box for the k. There should be something so that I can make it a cube number. If a number is a cube number, it means that their factors will also be a cube number. So here, if I want to make 2 as a cube number, I have to multiply 2 with 2 raised to power 1 and 3 with 3 raised to power 2. Same way, 5 with 5 raised to power 1. When I will do this, then you can see that what will happen. You will be able to see that our number will increase. Like first, I'm going to write this as 2 raised to power 2 times 3 raised to power 1 times 5 raised to power 2. So whenever I'm going to add with this number, like I'm going to multiply with this number times 2 raised to power 1, 5 raised to power 1, then you can see that my number will shift like these factors base is same, so power is going to add up. 2 plus 1 times base is same, power is going to add up. Same way, base is same, power is going to add up. And you can see now the prime factors are having the power of 3. So it means that this one is my value of k, which can make my my m as a cube number. So this will be 2 times, I'm going to split expand it, 2 times 3 raised to power 2 is 9 times 5. 9 5s are 45, 45 2s are, it's 90. So 90 is the smallest value of k, which can make my number as a cube. Express 500 as a product of its prime factor. 500, 2 2s are 4, 1 carry forward, 2 5s are 10, 0. 2 1s are 2, 2 2s are 4, 1 carry forward, 2 5s are 10, 2 6 are 12. Sorry, it is not divisible on 2. So we are going to choose 5. 5 2s are 10, 2 carry forward, and 5 5s are 25, 5 5s are 25, 5 1s are 5. It's 5 times 5 times 5, or we can write it as 2 raised to power 2 times 5 raised to power 2. It is 2 raised to power 2 times 5 raised to power 2 is my prime factor. Now next part says that find the value of P and Q. Let's write the values. Okay, here M was 2 into 3 raised to power 2 and the value of N is 2 raised to power 4 times 3 raised to power times 3 raised to power Q. As we are going to figure out the same variable together. As this is a 1 marks, okay, so still I'm just doing this for you so that you cannot, you should not be misunderstood with this step. I'm going to pick them, the same quantities together, 2 raised to power 4 and times 3 raised to power 2 times 3 raised to power 2 equals to 2 raised to power p times plus 4 times 3 raised to power 2 plus 2 p times 3 raised to power q. As I told you before, whenever the coefficient we want to make the base same, I will use this sign implies that, and I will make the same base together. 4 plus 1, 5. 5 is equal to 2 raised to power p. I can make them equal. Okay. Now same base is going to cancel out, and my p is going to be, power is going to be equal. So p will be 5. Same with q. Now let's do the same process for q. I'm going to make them equal to 4 equals to 3 raised to power q. This is going to cancel out. Same way, their power is going to be equal and q is equal to 4. Now it says that they are going to divide it up. Let's make them. So 2 raised to power 3 raised to power 2 over 2 raised to power 4 times 3 raised to power 2. Actually, it has mixed up with the indices chapter. So you have not done that with me right now. So in the next lecture, you will get to know it very easily. When you will be doing indices, you are going to solve them very easily. It's very easy chapter. Look now, I told you before, whenever the base is same, so power is going to be subtracted. For same base, power will be subtracted and it will become as 2 raised to power 1 minus 4. Same way, 3 raised to power 2 minus 2. This is equal to 2 raised to power q, p times 3 raised to power q. So let's make them equal. 2 raised to power minus 3 times 3 raised to power 0 equals to 2 raised to power p times 3 raised to power q. Now I'm going to use the same sign implies that, and I'm going to make the variables, the bases same. 3 raised to power t, 2 raised to power minus 3 is equal to 2 raised to power p, and their base is same, so it will be cancelled out and power is going to be automatically same. P is equal to minus 3, and for the value of q, by comparing the coefficients of q, like now let's compare these two values, and we can see that for these two by 2 power q, after cancellation of their same base, their power is going to be automatically same. So it will be 0. Actually, this is a 1 mark question. Okay, I have done so many steps just for you so that you can understand it. Otherwise, these all steps were not needed. Okay, from here it is part 2. This is part 2 from here. All right, now it says that n square. So let's do for n square. The value of n is, this is our value of n, 2 raised to power 4. This is our value of n, 2 raised to power 4 times 3 raised to power 2. 2 raised to power 4 times 3 raised to power 2, and we have to take the square. Let's take the square because it says that n square. So I'm solving this for n square first. N square. So whenever there is a power of power, the power of power is going to multiply individually under the bracket of this power on each term which are present in the bracket. Okay. And it will be written as 2 raised to power 4 times 2 is 8. Same way 3 raised to power 2 times 2 is 4. Now let's compare this with the this value which is present 2 raised to power p times 3 raised to power q. Procedure is same. Simply we are gonna compare their coefficients. First, I'm going to compare this because the bases are same, so power is gonna automatically same. I'm going to do this over here. You can see that 2 raised to power 8 is equal to 2 raised to power p. As base is gonna cancel out, so 8 is written over here. And again, now I'm going to compare with this one and this one. Let's compare these two. So for that, it will be implies, let's cancel out their bases, and it will be 4 equals to q. So my value of q is going to be 4. That will be my answer. I hope you have cleared your concepts till here. All right. Express 96 as a product of its prime factors. Okay, let's do that. 96. 2 raised to power 2, 2 fours are 8, 1 carry forward, 16, 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 3s are 6, 3 1s are 3. Okay, 1 2 3 4 5. 2 is 5 times. So times 2 times 2 times 3. We can write this as this one. Okay, next question. That is very important. Question, you need to understand it well. This question says that 24 is a common factor of 96 and n. That is a common factor, okay? And n is less than 96. Find the largest possible value of n. As it says that common factor. Let's find the factors for 96 first. The factors of 96 are 1, 2, 3. How many factors can be 3? 3, 4, 6, 8, 12. Because factor means that like it comes in the table of this, okay? It comes in the table of 12 as well. It comes in the table of 16 as well. 96 come in the table of 16. 96 come in the table of 24. 96 come in the table of 30. Same way in the 96. That will be the last one, okay? We have to write all the numbers in which it can be divisible, okay? That is meant by factor. Factors are those numbers which can divide this number in the equal part, like in the equal whole number, okay? They don't leave any decimal. And we have to do this till that last number. Now it says that 24 is a common factor of 96 and a number. There are two numbers. One is 96 and one is n. And 24 is a factor of these two numbers. It means that n is a multiple of 24. So now I need to write all the multiples of 24, and which will be, and it also says that n is less than 96. I'm going to write all the multiples of 24 which are less than 96. So let's do that. Multiples, these were the factors. Okay. So let's do the multiples. Multiples of 24. 24 threes are 72 and 24 fours are 96. We need to write, it says that n is less than 96 chance of having n, the value of n. So that is the possibly the value of n. So I will say that my value of n is 72. I hope you have cleared your concept part. Express 180 as the product of its prime factor. Let's do it. 180. 2 nines are 18, 0. 4s are 8, 1 carry forward, 2 5s are 10, 5 9s are 45, 3 3s are 9, and 2 times 5 times 3 times 3. So they will be written as 2 5. We will write them in order. 2 raised to power 2 and single time 5 and 3 raised to power 2. Okay, but in the order smallest number than the largest number than the this. Okay, you can directly, this is a 1 mark. Okay, they don't want you to write all working. Okay, they just want you to solve it. All right, now it says that express this in that form. Okay, that is, we are going to look at the prime factors first. These were my prime factors. These were the prime factors. Okay, we are going to follow these prime factors. So I'm going to write this as 180 is equal to under this over 2 times 5. There is one more thing which I have told you before in the many lectures, like last 2 lectures at least. If there is something in the square root, we can spread the square root if the values are being multiplied. So I'm going to split it up. Times square root 5. as square can cancel with the square root, this square can cancel with the square root 5. 3 2s are 6, so it will be 6 square root 5. Now let's compare these two values, like this one and this one. 6 and q is 5. Okay, so now it says that find the smallest value of p plus q. So p plus 11. So 11 is my value. A number is written as a product of its prime factor. Okay, evaluate this number. Simply multiply them. 2 raised to power 2 is 4. 5 raised to power 2 is 25 times 7. Let's multiply them. And it will be 25. 4s are 100. 100 times 7 is going to be 700. So 700 is our answer. Now it says that LCM of the number. Okay, let's do that. LCM of this number, and there is one more number n, and this one is LCM, which is given. This brown highlighted one is LCM. All right. So it says that find the lowest possible value of n key value. We need to find the value of n. Okay, I'm going to do this over here. So one number, suppose that this was equals to a. So my a number is having prime factors as 2 raised to power 2 times 5 raised to power 2 times 7. Okay, and my number LCM. The value of LCM is 2 raised to power 2 times 3 times 1 minute times 3 times 5 raised to power 2 times 7 raised to power 2. The trick is that whenever you have a question like this, you have to write those values which are not present. Like 2 raised to power 2 in LCM is present, so it was also present in this number. It means that I'm not going to write this. But 3, LCM is having 3, but my this number is not having 3. So I will write this 3. Same way, 5 raised to power 2 is present in my first number, so I'm not going to write this. Because it says the lowest possible value. Okay, highest possible value can be all numbers, because LCM contains all numbers which are common and non-common as well. Okay, loop ones and non-loop ones at the same time. Okay, but right now it says that lowest possible value. So I will pick all those values which are present in the LCM but not present in the value of A. Okay, so here 5 square is present. I'm not going to pick it up. 7 square. 7 square is not present over here. It's only 7. So I will consider this as 7 square. Now let's evaluate it. Let's multiply it, and after multiplication, it's going to be 3 times 7 square is 49. 49 times 3 is going to be 147. So 147 is my answer. That is my answer for n. Lowest possible value. Okay, that is the lowest possible value. Let's move to the next question. We have solved this question as well, so we are not going to do this again, but we can solve other questions. Let's do that. Express 60 as a product of its prime factor. Okay, let's do it. 60. 2 3s are 0 as it is. 2 1s are 2, 1 carry forward, 2 5s are 10, 3 5s are 15, and 5 1s are 5. So the prime factors are going to be 2, or we can write this as 2 square times 3 times 5. Now it says that what can be the smallest possible value of m, so that we can make our square 60m as a square number. This question says that the lowest number, that is a multiple of both 60 and integer n, is 180. Okay, so it has mentioned lowest number, which is LCM. Okay, and here are the two numbers n. So it says that find the possible value of n. We need to find the possible value of n. First, I'm going to resolve 180 into its prime factors. So 1 as it is, 2 4s are 2 4s are 8, 1 carry forward, 2 5s are 10. Now 3 1s are 3, 1 carry forward 15, 3 5s are 15, 3 5s are 15, and 5 1s are 5. So 180 is resolved into its prime factor, which are 2 times 2 times 3 times 3 times 5 times 3 raised to power 2 times 5. These are the prime factors of 180. Now this question shows that this is a similar question as we have done over here. Let me show you 1 minute. We have done the same kind of question over here. You can see that this one. This is the same question as we have done. Look, I told you before, whenever there were like the LCM was present and we were supposed to figure out the value of n. So what did we do? We have to write all the, because this is the lowest possible value or smallest possible value. So we have to pick all numbers which are not present in the this term, those are present in LCM. Okay. Same way we are going to choose the same procedure and we are going to do this over here. Look, here it says that 60 and n are two numbers whose LCM is 180. Okay, and we have resolved 180 into its prime factors. I'm going to write first number, which was 60, and the prime factors of 60 were this one. These were the prime factors of 60. So I'm going to write them 2 raised to power 2 times 3 times 5. And there is another number n. We need to is 2 raised to power 2 times 3 raised to power 2 times 5. Look, I took which are present in LCM but not present in this term. Okay, because we have to find the smallest possible or lowest possible value. So 3 raised to power 12 is the only value. 3 raised to power 12 is the only number which is not present in 60. So that is the smallest possible value which n can have, 3 raised to power 2. So our value will be 3 raised to power 2, which is 9. That will be our. Let's do this question. A number is written in the form of its prime factors. Okay. Evaluate this number. Let's multiply them simply. 2 raised to power 2 is 4 times 25 times 7. I think we have solved this question before, or it's okay. Yes, we have solved this question. This is the same question. Okay, in this question, it says that